Okay, now let's look at question 14. Question 14 basically, let's look at which side is more complex. They look like the denominator of the right hand side seem to be more complex, okay? Because this is 1 over 2 term, okay? If you have, so let's convert the right hand side. This is for question 14. Right hand side is 1 over secant theta is actually 1 over cosine minus this sine theta, cotangent is sine theta over cosine theta. Okay, next, let's combine the two terms which are the denominator, so it's 1 minus sine theta over cosine theta. Flip it over, it becomes cosine theta 1 minus sine theta. Okay, now the secant is here, the two brackets. You see, your right hand side, your left hand side don't have a denominator. Okay, that means you cannot have 1 minus sine theta. You have to think of way to remove it so that there's left with only a single term instead of the sum of two terms in the denominator. If there are two terms in the denominator, you cannot simplify it become like that. Okay, so the way is to plus sine theta 1 plus sine theta. Okay, with that you got cosine theta plus cosine times sine theta, cosine theta, sine theta. Okay, now at the bottom you got 1 minus sine theta square. Okay, and 1 using the identity, 1 minus sine theta actually become cosine square or cosine. Okay, sine theta square plus cosine theta square equal to 1. So cosine square theta is actually 1 minus sine theta square, which is this. So the denominator can be written as cosine square theta. Split the term in the two fractions, cosine theta over cosine square theta plus cosine theta sine theta over cosine square theta. This one cancel off, one of the cosine. This also cancel off. So what you left, let's continue from here. So what you have is 1 over cosine theta plus sine theta over cosine theta. That will give you secant theta plus tangent theta, which is equal to the right hand. In this case is equal to the right hand side. Okay, so therefore it's proof. Okay. Okay, now let's look at question 16. If you look at question 16, this seems to be more complicated in a sense because the denominator have two terms. Okay, so what we're going to do is we're going to try to remove the two terms in the denominator into a single term. Okay, for example, this is what I do. From here, these two terms, 1 minus cosine square theta, it becomes a single term, sine square theta. Okay, when you have this as a single term, it will be easier to continue. Okay, so now, the same thing exactly like what I did over here. This is 1 plus cosine theta. I'm going to multiply 1 minus cosine theta on the numerator and the denominator. So what happened is the numerator become 1. Since this and this is the same, so it become 1 minus cosine theta bracket square. But this is the case, the denominator is a k, a plus b, a minus b. Okay, so it becomes 1 square minus cosine square theta. But from the identity, if you make cosine square theta from here minus 1, oh sorry, it's the other way. Okay, it's the other way. So it's moving the cosine theta to the other side. Sine theta square equal to 1 minus cosine square theta. Okay, this is exactly like this. So it can be replaced by a sine square theta. Okay, now after that, you see here you have a square, here you have a square. So you actually can combine the term inside here, I mean the base for both. Okay, so what you do is you take out the common power, which is 2, and then you then group together. Okay, now so you have 1 minus cosine theta divided by sine theta, and then you split them. So it's 1 over sine theta, cosine theta over sine theta. 1 over sine theta is actually cosecant theta, and then cosine theta sine theta is cotangent. That's it. This is actually same as the left hand side. Okay.